His first job included coaching in XP by Kent Beck at JP Morgan Chase, and throughout his career, he has continued to implement agile and craftsmanship practices in a number of scenarios that stretch these values in different ways. He has leveraged the agile values and practices to build a successful software product that helped hedge funds manage multi-billion-dollar portfolios in near real time, and then applied agile practices in a larger organization with multiple distributed teams coordinating to deliver at a furious pace. Most recently, he has been working at LinkedIn, where he has successfully scaled agile and craftsmanship values across their flagship product engineering team. I'm happy to introduce Nikolai Avteniev.
When that intro is read out loud, it sounds way more impressive than what I think about what it is when I do. Thank you for that. So I'm going to talk, this is a very light topic. We're not going to have to do any serious thinking. And it's about collective code ownership and code review practices in LinkedIn, but generally it's about how these two interplay together, moving from individual code ownership to organizational code ownership. I work in a professional company, so we're going to have an agenda. I'll tell you a little bit about myself and why you might be here listening to me. I'll give you a big picture. That one was actually in the presentation, so I just kept it. I'll talk about empirical results in software engineering. So it's kind of that boundary between book and academia. It's a research paper on what's going on in the industry. So we'll talk about that a little bit. I'll tell you about our experience at LinkedIn with this boundary of ownership and code reviews and how that works out. And then at the end, if you have been convinced about my reasoning and kind of approach that I'm talking about, I'll have some takeaways for something that maybe you can do within your own organizations. Let's get started. First product I ever launched was in 2001. It wasn't much of a product. It was actually just a page that accepted resumes. I worked at a headhunting firm. Then I worked in all kinds of different industries. I went to banking, so I know about compliance and what Brian was talking about, and writing down everything that I do on a piece of paper before I actually implement it. And I remember the capability maturity model and trying to get leveled at a particular level. And then I thought, this must be what professional software engineering is like. It's software process improvement and CMMI. That's it. That's what I knew. And then somebody told us about Agile, and they brought in this guy, Kent Beck, and he was telling about XP. And we were doing test-driven development. I never heard of this. And we were pair programming, and we were writing test-driven development for JavaScript. So you can test UIs. Then from there, I went to work, having acquired all this new knowledge about Agile. I went to work on a little company. There's literally 3 people of us, and we were pair programming. So the 2 engineers were sitting at the same machine and doing this whole thing. It was a greenfield project, and so I was going to do it perfectly. And I thought this was what software engineering is like. It's, start from scratch. He's going to build the most beautiful software ever. You can talk to Audrey. She can tell you what that software really looks like. It wasn't the most beautiful software ever. Then I went to work in ad tech here in New York, and it was a much bigger company, way more teams, full of former thought workers. And I was like, okay, this is what software engineering is like. We're agile. We have many teams. We have all these thought workers telling us to do the right thing. This is it. This is perfect, right? And then one day, somebody gave me this book, and I read books. I still read books about software engineering. And I read all the agile books, and I read Extreme Programming Explained and the refactoring book. That was a mistake. Nobody should have given me that book, because that cost that business a lot of money. And then somebody gave me this other book, I'm going to talk about it in a second, that completely changed my view on everything that I ever believed. And I was like, oh man, all the stuff that I harped on about, all the making people do pair programming because it's the right thing to do, just really challenged my views there. What I do now is I work at LinkedIn, and at LinkedIn I did lots of different things. I started building backend systems and API services, then I helped build a data center, and now I'm working on the video product here in New York. We have a team in New York, it's about 80 engineers. We are hiring, we're building video and other products, I can tell you about that later. And one of the values of working in a big company like LinkedIn is to let you do all these great things on the side as well. So one of the things that I do by night is teach at City College of New York, and I teach a course in kind of software engineering, trying to bridge that gap between what is happening in schools and what we are doing in the industry and what skills are necessary, and if there's any gap there, that's what we're working on. If you want to learn more about the tech talent pipeline or the tech in residence core, I can tell you about it afterward as well. Okay, this is the book that changed my mind for like the second time. First time was I learned about Agile. Second time was Making Software by Andy Orman and Greg Wilson. They're the editors. It's actually a collection of essays based on empirical research in engineering, right? Sort of observing what's happening in the engineering space and trying to explain how these practices work in the real life in the industry. And this book will help you understand how to read empirical research, how to use it in your work, what to believe, what not to believe, and also has examples of all empirical research from industry sources about the kind of things that you do in your day-to-day work. Pair programming, code reviews, test-driven development. It's there. It's a good start. There's way more. This book is 2010, 2011. There's way more research that's been published since then, and we're going to cover some of that now. Okay, so here's the big picture. This is kind of, you're supposed to try to simplify your talk down to something really simple. So first thing that I'm going to try to convince you, if you're not convinced already, is that there is a relationship between code ownership, in this sense, I mean ownership not possession like licensing, but ownership, expertise about a particular code, having contributed and written to that code, and the quality of that code, right? So that's a relationship. How many people already believe that there is a relationship there? Okay, great. So half of my job is done. Cool. Second, code reviews are way more than a quality assurance measure. Like, it's actually mostly not about quality assurance. Okay? How many people believe that? Man, I probably don't even have to do the rest of this talk. This is great. And the final thing is that code review process, like putting in process in place in the organization, is actually a way to scale this idea of code ownership and expertise from individual to team to organizational level, right? Like, this is the overall idea here. This is what I'm trying to pitch you. And I'm going to kind of show you some empirical evidence from literature that talks about all this stuff. A little bit of disclosure. A lot of empirical research I'm going to talk about comes from Microsoft. It is not because they now own LinkedIn. I did most of this research way before the purchase was closed, and I don't think they bought us because of that research. So unrelated, but they do a lot of work, a lot of research in this area, and they talk a lot about code reviews and ownership, and they have the capacity and an organizational structure to actually be able to do this and help us further kind of the whole thing we're doing here, learning how to become better at building software. All right, and one more word about empirical results. They are usually gathered in a particular context, in context of an industry or in a context of a particular company. They won't necessarily generalize across. There might be some particular things in that context that make it invalid for your context. It's kind of like mileage will vary with empirical results. Its quality is really great when multiple different companies come up with the same results. That's when you know that there's real truth here. But it's good to kind of read and understand what's going on and what other people are doing and experiencing as well. So let's start with this, which is that code ownership has impact on quality. And here what I mean by, what these studies mean by ownership is the amount of contribution. So somebody who contributes a lot of code is considered to be an owner of that code, once again, not licensing. And quality in these particular studies talks about quality that's observed from the outside. This is not about the structure of the code. This is about the post-release defects or pre-release defects found in testing, right? So ownership is expertise, quality, or ownership is contribution of the code, quality is defects found in the wild. So the first study I'm going to talk about, the influence of organizational structure on quality, an empirical case study at Microsoft. What they wanted to find out is there something in the software engineering process that leads to particular aspects of quality in the software produced? And what they looked at first was whether the team and the ownership of the code and the structure of the team has any impact on the software that's being delivered. And the way that they went about that is looking at two things. Correlation, so they created these metrics for ownership of a particular code base, and they wanted to see if these metrics correlate with the propensity of a component to have a defect in it or not. And the second thing is they figured out, hey, can we predict using these measures of ownership if a particular component is going to be defective or not, right? And as a result of this, they were successful. So they actually built a predictor that they trained this on Windows Vista. I don't know why they chose that operating system, but that's what they did it for. And what they were able to do is build a predictor based on organizational structure, like, for example, number of contributors to a particular module, or what is the top-level manager to whom 75% of the contributions belong here, the hierarchy kind of things. And they built a predictor that was the most accurate predictor of defects than anything else they tried. It was more accurate than complexity of the code. It was more accurate than churn. Change in the code is more accurate than size, right? So this gives a hint that organization and how the contributors contribute to the code base has an impact on the quality of that code base, right? But you're already convinced of that, so you knew this, so you didn't need to know this information. All right. They did another study because they weren't convinced. And they wanted to get more information. And this study has a great title. It's Don't Touch My Code, Examining the Effects of Ownership on Software Quality. And here they wanted to get a little bit more specific about the ownership property and quality. So they identified this idea of contributors, how many people contributed to a particular code base, then ownership, which is the biggest contribution to a single person, what's that percentage? Then they identified minor contributors, people who contributed less than 5% of code changes, and major contributors, more than 5% of code changes. And what they found is that ownership, so the higher the ownership percentage, the better the quality was, right? So there's a negative correlation between ownership and quality, and defect propensity. So fewer defects if there's stronger ownership. And the other thing that they found is lots of minor contributors has the strongest correlation to more defects, right? So now we're getting into this weird situation where we all believe in collective code ownership, right? We understand all the practices or values here, but now we're learning through some empirical results, certainly at Microsoft, and this was expanded to Windows Vista and Windows 7. I don't know why, but those are the two ones they had. What they learned was that the stronger individual ownership, the better the quality of the software, right? So this is kind of starting to push back on our idea of collective code ownership and all the principles that were laid out in Agile software engineering. All right, so this is kind of where things get a little bit more interesting from the experience in the industry. And then they replicated the study again, Code Ownership and Software Quality, a replicated study. It wasn't a very great title. The first one was much better. And they reproduced this across Office, Office 365, and Exchange, and another version of Windows, unnamed version of Windows, but they did as well, where they found this again. They looked at that minor contributors leads to higher defects, and they did this at a source file level and a directory level before they were doing it at binary level. So they brought it down even further in the granularity. And they saw that for them, this relationship still existed. Strong individual ownership, fewer defects, lots of minor contributors, more defects, okay? This is not looking good for collective code ownership at this point. But even in this paper, they were like, hold on. Don't run off and try to put ownership constraints because it's going to affect all these other things like knowledge transfer, right? And you create this kind of bootstrap problem. If you have an expert who will do all the changes, they'll get more expertise, but when they leave, how do you bootstrap? Because the only way to be good is to be an expert. And it wasn't reproducible everywhere. So there was a study on open source code. It's called Code Ownership in Open Source Software. Not a very creative title, but it would have been way better if they said, Microsoft is wrong or something. And what they actually wanted to do is they wanted to replicate the study. In empirical research, replication is how you kind of prove that things are generally true, right? You start out truthy, and then the more replication you have, you get to truth eventually. And what they found is they didn't see this correlation in open source. and they looked at, I think, like 8 or 9 different Java open source projects, didn't see this correlation. They actually set out, they wanted to confirm the ownership law, but they couldn't confirm it in open source, so great. There's some room here. We can live in this world where it's not an absolute truth. They try to contribute it, they contributed this impact to the ownership structure in open source software. And they said there are these hero developers that contribute most of the code to most of the modules. And the contribution of minor contributors either doesn't exist or is not important enough. So there are other features that have greater importance in predicting defects in software engineering. And that was size. And size actually has a very close correlation with complexity. So if you're spending a lot of your time measuring complexity measures over your code base, you might be wasting your time. You might just measure size and get a pretty good proxy. Okay, so that was code ownership, right? We kind of know that there's a relationship. Code review. Okay, so let's talk about that a little bit. So there's a study called Convergence and Contemporary Software Peer Review Practices. Once again, done by Microsoft, but they look to Microsoft and open source projects altogether. And what they learned is, in a modern code review, it's usually a lightweight process. We're not talking about the inspection where everybody gets in the room and sits and reads the code together. We're talking tool-enabled, asynchronous, lightweight review processes, kind of like GitHub pull requests or something like that. And they looked at lots of different projects. They looked at a traditional system that was using the code inspection. They looked at code from AMD and Microsoft. They looked at 4 different open source repositories, and they looked at sponsored repositories. They looked at Chrome and what's the phone OS? Android, yes. So Chrome and Android. So they looked at those because they were available and well-structured. And they learned something from this, right? They learned that, skipped ahead. They learned that the process is lightweight, that the check-ins are frequent, and the reviews are quick. The median review that they found, and this was across most of these projects, was about an hour until you get the first review, and it was about a day before you get a committed review where you can ship it and get it done. They were small, the change sets were small, about 45 to 150 lines at the median mark, so these are all the properties they found. And they identified this shift that these discussions are no longer about defects. They're about kind of collective implementation. The people are working together to solve problems, right? That's one of the tendencies that they found. Another thing they found is that code reviews are actually, a different organization found code reviews are opinion forming, right? Processes, in process aspects and software dynamics of contemporary code reviews, once again, looked at open source and Microsoft together, and what they saw is that through code reviews, people form opinions of other people, and those opinions influence whether they'll accept their code review in the future, whether they'll do it, and it affects them differently. Some people say, oh, I know this person's not particularly clean with their reviews, so I'm going to spend more time with them, and others like, oh, this person's going to drain my time, is going to run away from this. They're time consuming. It's another thing they learned. 10 to 15% of surveyed developers, 10 to 15% of their time is spent writing code reviews, right? So they're not finding defects. What are they spending those 10 to 15% on, right? That's interesting. So we'll see about that in a second. So modern code reviews are multi-purpose. They're no longer about finding defects. They're about some other stuff. So what other stuff are they about? So 75% of code review comments are about maintainability of the code base. And this is one of those things that was replicated across different studies, open source, proprietary, even on students. It's kind of cruel to experiment on students, but they did it anyway. And they found this trend, and it's documented in expected outcomes and challenges of modern code reviews. This was a study within Microsoft where they found that only 14% of all comments were related to defects. And everything else, all discussions were about something else. 29% was code improvements. 22% was just trying to understand what this change is about. 16% were social communication. in the code review tool, right? So it's not about just defect finding. And when they asked the engineers and the managers ahead of time, why do you do code review? Why do we do code review at Microsoft? Both sets answered, finding defects. And then they looked at this data like, nope, that's not what we're doing. So what's the disconnect here? And they dug a little bit deeper into it, and they learned that you need way more context to do defect finding than you do to say, oh, this is misaligned, or hey, did you think of this library? So that's what the motivator is. This was consistent across multiple teams within Microsoft, not just Windows and Vista. So they did this on Microsoft Azure, Bing, Visual Studio, Exchange, Office, different teams, different setups, but they found the same kind of thing here, that mostly it's not about bugs, it's about other things. And it's mostly about maintainability. And this was later confirmed by survey results as well, where they sent to a broader swath of developers, why do you do code reviews? And it's basically about maintenance. And you can think about it as a perspective of the owner of the code, right? They want to maintain the code long term. So they're giving feedback and review that will kind of serve their need a little better. So now how about a contributor? Now you're putting up a code review. You're an author. What is that? How useful are the comments you're getting from reviewers? So about 65% of them are useful, right? And this was once again done at Microsoft. I told you to do a lot of research in this. They spend a lot of time on this to learn this. They did it across all the projects. It was consistent. Between 63 to 68% of the comments were considered useful. This is the recipient of the comment thought that this was a useful feedback and helped them improve on the code. So now we're looking at the perception of the reviewee rather than a reviewer. You can grow to give better comments. With growth, with more experience doing code reviews, not necessarily contributing to the code, but doing code reviews, your comment density of usefulness increases. So you can go to 80% after like 20 reviews or something. I think it actually may be smaller. And the bigger the review, the fewer useful comments you get, right? So once again, I'm getting integration to like make it smaller. Okay. And what the reviewers found most useful is when the owner of the code points out defects, right? So the most useful thing you can get from the code review is somebody pointing out the defect to you, but it's the least frequent feedback that you get in the code review, right? So you're starting to see this interplay between what reviewers need, what contributors need, what owners, maintainers are allowing, and then the relationship of code ownership here, right? Because the people giving a review, they are the experts. They are the owners of the code. All right, so experience at LinkedIn. I'm going to talk about the flagship product engineering team. Flagship team is made up of hundreds of engineers. We work on Android, iOS, web, and backend systems. Most of the backend systems are microservices. For the microservices, we have small repositories, each one for the different microservices, and kind of the team that's maintained them kind of owns it that way. For our bigger UI applications, we have systems that are, it's a big monorepo, and it supports lots of different teams, so it's a little bit of a different setup. All right. About our code review tech stack. We use Review Board to manage code reviews. You can check in unless it's been for a review. Somebody has to look at it. The owner of the project, they have to give it a ship it. We have extended review. We created Git review, which is a command that we use to manage our review board process. So that way you can really quickly create a review from your local branch and push it up. It tells you who the owners are, who you can contact them. It tells you how to contact them via Slack. So it enables our communication channel. We have ACLs on all our code. It's a fine-grained control over ownership. We restrict how many people can be in the ACL. Between 3, because we think 1 is too small, 2, once again, too small, and 3 is just enough, and 5 is the top. The idea here being is that this ACL is a level of expertise, and this is the people who can ship code that will go all the way to production, so you want to restrict that a little bit. We have a code review of conduct that we publish. It's a tool for everybody to understand how to do code reviews. Kibitzer is our bot. Kibitza is really helpful. It goes out and runs style checks, runs the tests, leaves comments in the code when things are broken in this change so that reviewers don't have to spend their time on this. We have Review Butler, which is a tool to analyze the SLAs from the platform team. Platform team needs to do reviews on lots of different commits, so we need to make sure that they can do it quickly. We also have a general analytics tool to help us understand how the review board process is going across all the teams. And we have RB Tracker that kind of lets each team manage their own backlog of RBs that are coming into them. This is the total system. So how does it work? At LinkedIn, any individual developer can contribute to any repository that exists at LinkedIn, right? Everybody uses the same review process. Git review will help you find the right owners who will need to give you the shipment on this. All the owners of the code get notifications via email, or you can find them on a Slack channel and get them. They can apply the changes locally. They can take the diff, apply it locally, see it in the IDE, and really get the full context that's necessary to actually do a thorough code review. This is where Kibitza bot comes in as well. You put up a review, it goes off and does its work and tells you that your code change looks good, it's not going to break anything, or it looks bad and you need to change it. Communication happens over the RB itself, or in Slack, or over email, or in person. We prefer to have higher bandwidth communications channels when there's really confusion around the issue, right? So if you really can't understand what this code is doing, you go talk to somebody or have a VC with them. Once all this is done, you get to ship it. You, once again, do git review submit, and that pushes it to trunk, and our continuous deployment automation pipeline takes over from there. All right, and of course we have reporting on all of this, so we can see where in the pipeline there are problems, where the bottlenecks are forming. Is there a team that's really having a hard time getting code pushed out? That's our process. And we're going to do a deep dive here onto the Neptune code base. Neptune is a nickname for our web application. It is a monorepo, probably several hundred lines of code of JavaScript. It is built on a stack we call Pemberley. It's a play on words between the Play framework and the Ember.js framework. So it's a lot of JavaScript. And it supports dozens of teams, right? So it's one monorepo with dozens of teams contributing in it many times per day, right? This is research that was actually done by my coworkers at LinkedIn here in New York, Evan Ferreira and Shane Afsa. They are web engineers here in New York office working on Neptune. So what we saw, what we reviewed is about 2,000, we reviewed about 400 reviews, about 2,000 review comments, right? I'm trying to add empirical data and support to the findings that Microsoft found as well. 47% of this were solution approaches, 10% documentation, 7% defects, and 7% false positives. The rest of this was like organization in the code, right? So we're seeing very similar, two different organizations. I know we're one organization now, but we're still two different organizations with practices that evolved in different ways over different timelines, but similar effects, right? Mostly not doing defects. It's mostly solution structure and kind of maintainability properties and future growth of the code base, not necessarily defect finding, okay? And then we looked at different teams. Is this something that goes across many different teams because we have different ACLs? And it's pretty consistent. For most, with the exception of messaging. Messaging is really good at finding defects, apparently. Most of it is solution approach or some other maintenance or evolvability property. That's where most of the comments are coming from, more than 70%, right? So once again, we're seeing this fact that these code reviews are beyond defects. They're about knowledge transfer. They're about maintainability of the code base moving forward. Now about the usefulness, right? So that was from the view of the reviewer and what they're providing. This is the usefulness. So 51% are considered useful. 26% are somewhat useful. Microsoft combines those into two. So about 80% of feedback that we're getting is useful feedback, and the comments are useful. 10% not useful at all. This is mostly kind of like false positives. And then 12% are compliments, which is great. It's actually great to see compliments in codebase. It's helpful when somebody notices somebody does good work and says, hey, thank you. And then if you look at this by the type of type of comment reported. Of course, people receiving the reviews find defects most useful, right? Once again, this is replicating what Microsoft kind of found. So we're getting some consistency here. I'm pretty convinced that if most of you do this in your organization, you're going to find something similar, right? So defects are most useful, but we're not finding defects. Most of it is maintainability of the code base. All right. And this is about timing. Once again, median time to first review is about 45 minutes. That's the first dark line. Median time to commit is about a day, right? This can get pretty expensive, right? So code review process is not, doesn't necessarily need to be fast. It could be, but sometimes it takes some time. And more than 25% of reviews don't get a first comment for like 14 hours, right? So sometimes it takes a while. And more than 25% or up don't take more than 4 days to actually commit to production. So introducing code review process into your pipeline will slow some things down for some of the time. So kind of be ready for this. All right, so hopefully you're still with me, and now you're prepared to roll this process out in your organization, right? So here's some takeaways to kind of take back to your organization if you want to go ahead and roll out a code review process. So allocate time. Reviews take time, like we said, about 6 to 10 hours. More senior people get, the more time they spend doing code reviews, actually. So you'll need to allocate some time for those people to do the right job. And you can't actually do a good job of code reviews if you rush through it. Code review is a culture change. It's not just a new process you implement. Getting people to share code with others and put it to some sort of judgment or feedback will be challenging. Not everybody's going to enjoy it. You might have to change your hiring practices. You might change your evaluation practices for promotion. At LinkedIn, code reviews are considered during promotion packets. Your promotion packets literally have code reviews you've done, meaning reviews you've given, and also code that you've submitted via code review. So you need to participate. There's no way not to participate in code reviews. Expect delays in your product delivery, right? Code review pipeline, if you don't have one now, you insert it, some things will take a little bit longer. You need to instrument your code review process so you can find where the bottlenecks are and see how to improve them and what we need to change things. And final thought on this, it is not a QA process. You can't depend on code reviews to find all your bugs for you. It's an addition to other QA processes. So you have testing already implemented, great. This will give you a leg up on that. But don't expect this to catch all your bugs. It won't. Okay. For the code owner, AKA reviewer, AKA the expert of the code, right? Here are some tips. Take your time. So don't rush through reviews. You will miss defects. Finding defects is the thing that takes the most time, and it's the most useful for the people whose code you're reviewing. But hurry up, right? The people are waiting, right? They submitted the code for review. They're trying to get something done. They're trying to contribute to your code base to make your code base much better, right? They're adding some feature. They're extending the ability of your service. So respond to them in a timely fashion. Don't do it all at once. If you try to say, I'm going to spend all day today doing reviews, don't do it. Your effectiveness at finding defects drops the more time you spend on this. So don't approach this way. Do more frequent reviews, but of smaller chunks of code. Communicate compassionately. So there's a great slideshow out there, Mindful Communication and Code Reviews. It talks about a good way to give comments on code reviews. Read that slideshow, use those approaches, right? Try to understand the reviewer is trying to help you. They're trying to enhance your service. Understand how they're doing it, why they're doing it. You're probably doing the code they're doing for a very good reason. They're not just trying to hack it together. Okay, and don't nitpick. Really don't. Remember, you are the owner and the expert in this. If you feel that this particular thing is something that is not a big deal and the code can continue, you can always go back and clean it up, right? So don't be like, oh, but if you just format this line or if you just move this method to the other line, that would be perfect. Don't do that. You can clean it up later. I once had my review stop from going forward because somebody said, oh, in our style guide, this the arguments need to go on the next line. They can't be in the same line. And I ran the automatic style guide shade and I said, no, it's not. I ran the check. It's not there. He goes, oh, no, it's in this document. And then it was like point 2, point 8, point 3, point 5. Here, like, I had to go read this document. I was like, don't do this. Well, you held up my review for more than a day because this tiny little thing, I'm trying to add value here to your code base. It's not mine. All right. The other way around, this is for the code authors, aka contributors, people who want their contribution to be submitted and accepted. Take your time. Same advice. Prepare for a code review. Run the tests. Run the style guide. Run whatever static check analysis you have, right? Please do it, because that will catch a bunch of stuff. Actually read your own code for review. In the review tool, a lot of stuff you can read, you'll find the bugs. You can do a self-inspection and catch most, like 70% of your own problems. So do that first, okay? Please make it small changes. Small changes get better quality of feedback, they get more engagement, they get reviewed faster. It's better for everybody to make it smaller change sets. Please do that, please. Hurry up. But in a different way. So respond to feedback in a timely manner, right? If the maintainer actually took the time to talk to you about your code and they're giving you feedback, respond to them. Talk to them. Find the right reviewers. Don't just blast the mailing list. Don't look at the Slack channel, look at all the names in the Slack channel, and just drop that into the reviewers. No, find the ACL owners. Find somebody who might be, if there's an on-call rotation for review boards for that organization, find the right people who can give you the right feedback, okay? And then talk to them. And once again, communicate compassionately. Remember, you are here just for this one contribution. They're here to maintain this code base in perpetuity. So try to find a language and understanding between the two of you of how to move forward to get this contribution made, and let them do their job, which is be able to maintain their code base effectively. All right, that's it. And since I talked so much about empirical research, here are my references. Here's one, and here's the other. Do we have time for questions?
Just about 2 questions, yeah.
Okay.
Do you have any checklists or templates that you use to maybe boost the odds of finding defects?
I know internally we have lots of different teams with their own specific checklists. I don't have one off the top of my mind that I can name. We do have some. They're not mandatory. Josh Hartman, who's the director of engineering at LinkedIn, Joshua Hartman, and he used to be principal staff engineer, and now he's director of engineering. He wrote a blog post on LinkedIn that details his checklist. And Josh was one of the most prolific reviewers, an incredibly capable engineer. So if you follow that checklist, I'm sure you'll be able to find lots of those.
Cool, thank you.
I'm a bit surprised. There's nothing about testing and the things that were most reviewed about or most valuable about. But I found out by code reviews that comments on the quality of the test and the testing strategy were very insightful. Is that you got any insight over these or?
I don't remember off the top of my head. Nothing jumps out from what I read that talks specifically about it. There's some there are some papers that talk about how you can include testing in when you put up the code review, and that will improve the quality. But I don't, off the top of my head, I don't remember. Sorry. Can we do one more since that wasn't an answer? All right. Sorry.
Nikolai, was the code review tech stack that you mentioned specific to LinkedIn, or is it something that like other companies could
The one
replicate?
I talked about was specific to LinkedIn because I don't think any other company with 3,500 engineers actually uses Review Board. Google and Facebook have something very similar. They have, but they build their own like from scratch. But they have very similar process. You know, there's reviews are done before check-in. There's automated systems that are signaled by the new review created, and they do static analysis on the work, and then they push to production. Google has actually given a talk about how they do this at the end of May at a international software engineering conference. So that will probably be a lot of data and a lot of useful tips from what you can do there.
So we actually have time for one more, if anyone has one final question.
Can you talk about pair programming was something in XP that came out a lot, and we used to do that a lot.
Mm-hmm.
You have a comment of that instead of doing code reviews?
I have lots of comments. So on that particular practice, like my first peer review process was a pair programming, right? At Chase, there was no code review. We didn't do inspections. So when we started doing Agile, we did pair programming. It was the first time anybody looked at my code before I thought it was ready. And of all people, it was Kent Beck. Imagine the shame I experienced. So I think of it as a continuum, right? So you have complete individual ownership where it's just that, right? Nobody looks at my code. You just tell me what to do, and then I'll tell you when it's done, right? Then I think pair programming is the next step up, right? Where there's at least one person, or there's at least a culture of people looking at each other's code. I think a code review program, one that's applied to the entire organization, is a step beyond that. Now you've moved past the pair programming and transferring knowledge within the organization, within the team, of having this process of how to contribute and transfer knowledge across your entire organization, right? One of my students actually did research on this, and they found a paper, and I'm citing my student citing a paper, so that said that somebody looked at the quality of pair programming, compared that to pair reviewing, meaning you don't write pair programming together, but you review the code together, side by side. And they found that those processes are just as effective for the quality of code and finding defects, but the pair review is cheaper because of this idea that you two are writing code at the same time and then pair reviewing together. So that's the only thing that I have that's related to this. There is lots of empirical research on pair programming, the effective practices. And there was anybody here from Pivotal? No? Well, I guess it's a kind of competition. But they published a great paper about how they use pair programming to transfer knowledge across the project, across the organization. I don't remember off the top of my head. I can look it up, though. Okay. Thank you very much.